So here is the take-home quiz. We have this then, good old Anne. If you want to know what your test is going to be like, Sierra, look at both quizzes. I'm not throwing anything weird or new at you. So I like number one. I like number one. Number one is a nice question. Rihanna, what's number one asking me to find when it says how long? Okay. So the first thing I did was write this down. And then I want to walk through my procedure. Is there more than one object moving at different speeds? This is a job, Oliver, for relative speed. So I'm going to say VREL equals, they're coming towards each other, one at 10, one at 6. Is their relative speed 16 or 4? What's a dumb, clever way that I can remember whether I add or subtract? Head-on collisions are worse. Now, also, if they're heading away from each other, that's the opposite of a head-on collision, but you'll still add. It's when they're going in the same direction, bigger minus smaller. So the relative speed is going to be 16. I'm going to argue that to pass, the back of the first train has to get past the back of the second train. In other words, I'm going to argue the total distance here, Emma, is 120 plus 450 plus 80. 120 and 80 is 200. 650, is that right? Now, I'm doing some of the math in my head. Of course, on a test, I would use a calculator. Now, let's put some teeth to this. What we're going to be using is this equation here. D equals V relative T. Technically plus a half AT squared, but why don't I have to write the plus a half AT squared in this particular unit? A equals 0. And also in Einstein's special relativity, it really should be called special case relativity. What's the special case? A is 0. He didn't know how to deal with acceleration yet. Without acceleration, you can get relativity out of Pythagoras and a little bit of cleverness. When you add acceleration, you get tensor fields and three-dimensional math, and we'll talk a little bit about that today maybe. T is going to be D over V, so it's going to be 650 divided by 16. $650 divided by 16. You get 40.6. I'll go 40.6. 41 I would take as well. 40 seconds I would say take a half mark off, learn to round off. So I'm going to go 40.6 seconds. Yeah, 3 sig figs looks like what my data is. If you got that, 3 out of 3. Otherwise, I would probably do 1 mark if I saw that you had used the relative speed. I would probably give you 1 mark if somewhere I saw that you would realize that time is distance divided by speed. And then 1 mark for the answer. I think on your test, though, I made this one worth 2 marks, not 3 marks, because it seemed a little overkill. Number 2, very similar to number 1, except they're going in the same direction. Again, I'm going to argue that the distance we need... Whoop, that's wrong. The distance we need to travel is that distance there. Again, it wants us to find time. The distance in this case is 150 plus 450 plus 100. 150 plus 450 is 600. Is it 700 is the distance, I think? And is there more than one object moving? Are they moving at different speeds? This is a job for relative speed. In this case, is the relative speed 18 or 8? 8. Same deal. D equals VT. So that means T equals D over V. It's going to be 700 divided by 8. I think this might work out almost evenly to a nice decimal. 87.5, is that right? Seconds. Did I put the right units on the last question? I did. So if you got that, Cole, 3 out of 3. Otherwise, again, I would probably give you 1 mark if you would use the correct relative speed. I would give you 1 mark if I saw that you would realize time is D over V, and then 1 mark for the answer. Now we're getting into special relativity and relativistic speeds because I see the letter C. They want me to find a length. Is this question asking me to find L or L0? L? So that must mean they've told me L0, the original length at rest, 620. Looks like the speed is 0.96 c. What's another way that I could write that, or sorry, type that out in English? Instead of typing out 0.96 c, what does that really mean? Okay, so I'll have no problem, Emma, saying 96% of the speed of light on your test as well. And I'll expect you to say, oh, 96%, 0.96 of the speed of light. C. Is the length equation L0 times gamma or divided by? I don't have these memorized. I don't have my sheet here. Times? Okay. So it's going to be 600 times the square root of 1 minus 0.96 c over c squared. Do you see? Do you see? Do you see? Yes, I see. 620. Why did I write 600? Because I can't read my own writing, apparently. So it's going to end up being 620 times the square root of bracket 1 minus 0.96 squared. You get it? Wow. 173.6. I'll go 174, but 173.6 is fine. Units, meters. Now, I was getting into a big philosophical discussion earlier today with one of my students, because the student kept saying, but Mr. Dewitt, that's not the real length of this, right? The real length is still 620. And I said to him, you can't use the word real length, because that 174 that the people at rest now measure, there is no experiment in the universe that they could do which would give them a different answer than 174 meters. So that is its, quote, real length now. It's what it is. When its speed changes, its length will change. And this is the part of relativity that's uncomfortable to us because, Tristan, we don't have experience traveling near the speed of light. All of this stuff is happening all around us all the time, but we're going so slowly it's negligible. Is it 174? Yeah. 2 out of 2 if you had 173.6, 174. Half mark off if you forgot the units. Otherwise, I would probably do something like this. Oh, heck. I think I would probably do half mark for the equation, 1 mark for the numbers, half mark for the answer, or something like that. Question? Yep. For which one? For M, for mass? Yeah. Mass. So for L0 and M0, there I think L original at rest and mass original at rest. Time is the different one. And it's, by the way, it's really not. It's because Einstein thought everything was relative. He actually, anyways, it makes sense if you get into Einstein's brain, but I only get there once in a while. Number 4, they're asking me to find the length. I think they're asking me to find, no, not L0. They're asking me to find the actual relativistic length because it's measured to be. There's one of my key phrases. So that means the original length at rest is 45. But Mr. Dewick, how could this ever be an at-rest length? If you were on the spaceship, aren't you at rest as far as you're concerned? But you would not notice any difference. You would measure the spaceship to be 620 meters long in your reference frame. You would see the rest of space moving past you and being shorter and squooshed. It's really, you get into some weird stuff with relativity. It's one of the reasons I like it. V is 0.98 c, so we're going to get L equals L0 times the gamma function. It's going to be 45 times the square root of 1 minus 0.98 c over c all squared. Do you see? Do you see? Yes, I see. What if I didn't give you the speed as a percentage of light? What if I gave you that in meters per second? What would you have to have down here in the bottom of this fraction? 3 times 10 to the 8th. I'll do that maybe twice on the test because I much prefer to do it as a percentage of the speed of light. But, Christy, I think at least once I'll probably throw it at you. Okay. 45 square root of 1 minus 0.98 squared. 8.95? Yeah? Same marking scheme as before. Half mark for the equation, 1 mark, half mark for the answer. So Emma, now we're answering your question about mass. It says, what would the mass of this rock be at this speed? So they're asking me to find the relativistic mass. m0 is the original mass at rest. The speed is 0.99 c. This time, is it m0 divided by the gamma factor in mass? We divide? Yeah. So it's going to be 65 divided by 1 minus 0.99 c over c squared. Do I see? Do I see? Do I see? Yes, I see. So if I want to type this in, it's going to be 65 divided by square root bracket 1 minus 0.99 squared. So you may be at the point where you've practiced enough with your calculators, Christian, that you don't have to go the way we've been doing it, which is to do each step one step at a time and use your answer button and work your way out. Do you get 461? 460.8? I'll go 461 kilograms. Half mark, 1 mark, half mark. Then we turn the page. What's this question asking me to find? A length. Which one? L0. The at rest length. So the relativistic length that we measure it to be is 144. The speed that it zips past us at is 0.98 c. So now I got to get the L0 by itself. Do you get L0 equals L divided by the gamma, the square root thingy? Is that right? Yeah. Okay. So it's going to be 144 divided by the square root of 1 minus 0.98 c over c all squared. Hey, the c cancels. Yay. 144 divided by square root of 1 minus 0.98 squared. 723.6, which, if you're a Star Trek nerd like me, is the actual length of the Enterprise. I looked it up on the Star Trek Wikipedia because I had to do it right. I'll go 724 meters. Wait a minute, Mr. Dewick. There's no such thing as the actual length. Good point, Misha. It's the fictional, made-up, at-rest length of the Enterprise based on the specifications that the wiki had. Same as before. Whoop. Don't want to do that, Mr. D. Same as before. Half mark, 1 mark, half mark. Good stretch, Mike? Yeah? Friend borrows your red Ferrari spaceship model X119. So I'm thinking the Ferrari looks kind of like this, and let's pretend it's going that way. So this distance here is 18 meters, and this distance here is 5.6. Which distance is going to change? The 18, the 5.6, or both? Just the 18. It's going to end up looking really short and stubby, but its height is not going to change, because Einstein says lengths only change in the direction of travel. So this wants me to find L. The original length at rest is 18 meters. The speed is 95% at the speed of light. That's a good Ferrari. So L is going to be L0 times the gamma function, I think. Do I see? Do I see? Yes, I see. 18 square root of 1 minus 0.95 squared. Do you get 5.62? No? Yeah? By the way, what was the original width? What's the question say? 5.6. What's our relativistic length? 5. This long rectangular Lamborghini would look almost square now. Very close. In fact, probably your eye wouldn't be able to tell that it wasn't square because those are so close together. I doubt your eye could pick the 2 centimeter difference. Did you do that on purpose? Maybe. Well, since we're going fast, time is different. So your friend has been gone for 5 hours of your time. Where am I? Back home on Earth. So they have just given me T. They want me to find time on board. My friend will have experienced less time than me. What was the speed? 95% of C? So I want to find T. T equals T0 divided by the Lorentz factor? Sorry, they want me to find T0. So Sierra, duh. Is it going to be T0 equals T times the Lorentz factor? Is that right? I'm going from memory here, and I haven't really memorized these equations because they're pretty ugly. 5 square root of 1 minus 0.95 C over C all squared. The C cancels. I get 5 square root 1 minus 0.95 squared. Do you get 1.56? And this one is in hours. If I gave you the same question in years, you would be back in 1.56 years. Decades, 1.56 decades. Last page. Okay. This is asking us to find V. Which one is M0? How do you know? Okay, I've noticed that mass gets bigger, so the M0, if you're looking maybe, Emma, for another dumb way to remember, since 0 is the smallest whole number, M0 is going to be the smallest mass. I don't know. Whatever works for you. 2 to 4. Really what I'm saying is, how fast do you need to go to double your mass? V equals C square root of 1 minus, is it M0 over M all squared, or is it M over M0 all squared? Is that one? Okay. Total guess, but I kind of have a dumb way to keep them straight. Did I tell you whether I wanted it in meters per second or as a percentage? So, Hannah, I'll take either. On the test, I just finished photocopying the test this morning. I bold fonted it very clearly. There's, I think, 4 times we're asking you to find a speed, and I say, give me your answer as a percentage of the speed of light to 4 sig figs. Or give me your answer as a in meters per second to 4 sig figs. Emma Cole needs your help. I'm going to do it once like this. You back now? I don't think you are. Time was really moving slowly for you. Oh, Mr. Dewick, I was traveling right at light speed. Yeah, no kidding. You were definitely in the dark for a while. That's what I would say. Dope. So the square root ends up being 1 minus 2 squared over 4 squared, or 2 divided by 4 all squared. Do you get 0.866? Okay, so I'll take 2 answers. I'll take 86.6% of C. If you stopped there, because I didn't tell you which one I wanted, Sierra, I'll give you full credit for that. Or, if I want to take this and actually get an answer, I multiply it by the speed of light to get meters per second. I tend to go to 4 sig figs because all these are so close to the speed of light. Every decimal does matter. So 2.598 times 10 to the 8th meters per second. I'll take either one of those. Or both. Okay. So basically, if you want to age half as fast as someone else, 86.6% of the speed of light is the doubling factor. That's the magic number. I like number 9. I like number 9. I like number 9. Number 9 is a nice question. Keyword in 9A, stationary. So for 9a, we're not going at relativistic speeds yet, Emma. We can just use our d equals vt equation, not the fancy schmancy Einstein-y one, and they want to get time by itself, so it's going to be d over v. The distance is 40 light years. The speed is 0.995 c. That light, and that one cancel out. I end up going 40 divided by 0.995, and they get 40.2. Because they're almost going the speed of light. They're going slightly slower than the speed of light. So, Christy, that answer makes sense. It should take them a little bit longer than light to get there. Now, it's not going to make sense because that's relative to us. How long will they experience on the spaceship, Emma? Well, now we want to find for part B times 0, where time back home was our answer from part A. Our speed is still 99.5% of the speed of light. T0 equals t times the gamma function, I believe, yes? It's going to be 40.2 times 1 minus 0.995 c over c all squared. Do you see? Instead of using 40.2, I'm going to use my answer button. You get, wow, 4.02 years? 4.0 years? It's almost a 10-to-1 relationship. Not quite, but close. 4.02 years. What is the distance traveled? So there's two ways to do C. One way is to say, well, distance is speed times time. Distance is 0.995 c times 4.02 years. And the time, since that's the speed that we're moving at on the spaceship, I'll use the time that we're experiencing on the spaceship. And if I do that, I'll get that even though the Earth thinks that it's 40 light years away, the spaceship will measure that it's 3.99 light years away. The other way you could do that, Christian, is from the frame of reference of the Earth. Of the spaceship itself, if we assume the spaceship is at rest and all of space-time is being distorted. So we could find L when the original length is 40 and the speed is 0.995 c. I can go L equals L0 times the gamma function. It's going to be L0 40 times the square root of 1 minus 0.995 c over c all squared. And if I'm lucky, I'll get exactly bang on the same answer. Here we go. Oh, look at that. Even to the 9th decimal place, bang on. I'll take either approach. Light years, Mr. Duke, not years. Light years. I really need to figure out the abbreviation for light years. There's going to be at least one of those on your test because that's just plain cool, Maggie. The fact that there is no way to measure distance accurately in outer space. It depends on how fast you're moving. And the faster you want to measure the distance by traveling the fastest, the more your answer is going to be different from everybody at rest. Kind of cool. Can you give yourself a lovely score, please, out of 26? Right there.